I'm thrilled to be given this chance, especially to talk about something that I'm like really deeply passionate about. And so I wanted to first start this talk off by telling you a little bit about myself and how I became a scientist, give an overview of my graduate studies from University College Dublin, and then how I became so obsessed with fiber and gut health. And just as a means of disclosure, I am a postdoctoral researcher at AstraZeneca, but there's no conflict of interest because the information that's in this talk has nothing to do with the work that I'm doing there currently. And so the title of my talk is The Proof is in the Poo, Dietary Fiber, Gut Health and the Obesity Epidemic. And as Jim introducing, my name is Dr. Serena Kajani, and I wanted to start this talk off by introducing it's baby Serena, or as my friends like to call me, Saz. And so Saz is about 11 here, and she loved cake, evidently. And when I was younger and chubbier, I also had other problems like asthma and eczema. But as I grew into early adulthood, I got into exercise and making healthier food choices. And now I'm a normal, healthy weight for a nearly 30-year-old woman. But I could have gone down a different route in that I could have kept eating the cake and the chocolate and the crisps, and I could be 20, 30 or 40 pounds heavier than I am now. And with that obesity comes the comorbidities such as heart disease and diabetes. And so that is what we're dealing with in my home country now, Ireland. As a nation, we are set to be the fattest European nation by 2030. So that's only 10 years from now, with 90% of us being deemed as overweight or obese. And this is not isolated to Ireland. We see this trend occurring in the United States, in the UK and Australia. And what I need to highlight here is that obesity is not a cosmetic issue. It's a very real health issue with numerous complications such as heart disease, fatty liver disease, diabetes, as well as others like cancer, asthma, infertility, and joint problems. Not only is this a massive healthcare cost to the patient themselves, one that potentially could be avoided, but I'm sure we all know someone that is suffering from these diseases and how debilitating that can be. I know for my dad, who is a heart patient, his quality of life hasn't been the same since his heart attack. It's actually funny because when I was younger and I'd come home from school, my dad would, he'd always remark on how chubby I was. And so I'd come in and he'd be like, Serena, you're looking healthy. Very healthy. Too healthy. And I'd just be like, oh, Dad, like, it's just a bit of puppy fat, like, relax. And he's like, puppy fat? It looks like you took the whole liter with you. And so he's kind of partly the reason why I got into the line of research that I'm in. And so my research was really specific, and it looked at heart disease. And I looked at heart disease within the obese setting. And so it really focused on cholesterol. I'm sure everyone has heard of good cholesterol and bad cholesterol, but what distinguishes the two? And so good cholesterol is also known as high density lipoprotein, or HDL. And so HDL acts like the garbage man of the body, and it picks up cholesterol from arteries and other cells and acts as a transporter to bring that cholesterol to the liver, where it's eventually excreted. And so this process prevents heart disease by reducing the amount of cholesterol in one's body. And for anyone that's interested, just get my little laser pointer here. This is what HDL actually looks like. So we have this shell of proteins surrounding this cholesterol core. And so LDL, which is the bad cholesterol, does the opposite and acts as a dump truck, promoting putting cholesterol to where it needs to be in the body and where it's needed. And this balance between, this balance between HDL and LDL for removing and depositing cholesterol is a normal part of human physiology. However, when this balance is taken off course, where the LDL deposits too much or the HDL doesn't take enough, we become more at risk of heart disease. And so what do we think happens? What does obesity do to our HDL? Well, basically, it takes it out of work. And HDL can't do its job properly. Cholesterol builds up in the arteries and gets blocked, and bam, heart attack. That's what happens. But how does obesity manage to do this to HDL? And in my previous lab, we believed it was the immune system and inflammation. And so in a normal, healthy situation, our immune system fends off disease and infection like a light switch. When the infection is present, the immune system is alerted and it turns on. But then when the infection is gone, it's turned off. But in obesity, it's a different story. And so in our tissue, let me get rid of that little laser pointer, go away. In our tissue, there are fat cells. And they take in the fat that we eat. And so fat cells tend to have a bad rap in normal media, but they're actually really important in storing the fat that we eat. And when they take on too much than they can handle, they end up bursting open and the fat goes to other organs like the liver. And so because the cells have died, immune cells then infiltrate the area, thinking that there's an infection present, and alert other cells by releasing pro-inflammatory chemicals to come to the area. And so what we have is that a person gets more obese and the more fat cells burst, and then this immune system, this immune action occurs throughout the body, causing a state of chronic low-grade inflammation. So it's more like a dimmer switch. And so your body is sending out these pro-inflammatory signals, and this interacts with the HDL, causing HDL to dysfunction, and thus can't fulfill its role of ridding the body of cholesterol. And so, as I mentioned earlier, when I was bigger, as an adolescent and early adult, I was about 70 pounds heavier. I had asthma and eczema, and these are both inflammatory diseases by nature. And when I lost the weight, they both disappeared. And I appreciate that this is just anecdotal evidence, but I'm sure you can appreciate that there is a link between obesity and inflammation. And so we try to get people to lose weight, like eating well and exercising. And while lifestyle intervention is preferable, people just don't stick to them. And those that do are rarely successful. And so I was very lucky in that I was able to lose the weight, but 8 out of 10 people who try to lose weight generally won't succeed. And so public health strategies to get people to lose weight have failed. And we're coming to a situation where diabetes and heart disease are of epidemic proportions that the healthcare system cannot sustain. And so we need a new strategy to combat these diseases. And so our lab set out to answer this question. If obesity causes inflammation, which then causes HDL not to function, which then in turn increases your risk of heart disease, but if we stop the inflammation at its source, can we prevent HDL losing its ability to transport cholesterol and thereby prevent heart disease? And so recruiting humans for a study is actually a pain in the bum. Joe down the road is doing Pilates, and Mary's off playing bridge on Wednesdays. It's a bunch of red tape. And you know what? We just chose that the humble mouse was a better model to study this. And so we treat these mice really nicely in that they have comfy little homes and they're given takeout every night. In that we feed them 60% high-fat diet. And so one group gets the high-fat diet and then the other group gets a drug. And this drug is actually a sister compound to aspirin, so it's an anti-inflammatory. But I call it Sasprin because my name is Saz and it's aspirin. It's patent pending, okay? Like I'm dealing with marketing. It'll work out, I'm sure. And so we do this for 24 weeks. And after 24 weeks, these mice are super fat. And at that point, we do 3 things. Oh, Jesus. So first, we look at the fat cells under the microscope to see if they've expanded and burst. And then we look at the immune cells in their fat tissue and culture them in a plate and see what chemicals they're releasing. And the third thing we do is that we take a blood sample, and from that blood sample, we can separate out the HDL and see how efficiently their garbage men are working. And so first off, when we look at these fat cells between these groups, we can see that the high-fat diet treated mice, their cells are large and broken. And I'm not sure if you can see it very well, but they're little purple dots. Those are actually immune cells that have infiltrated the area, showing that there's an immune response. But with the mice that were treated with the high-fat diet and the drug, I'm sure you can appreciate that the cells are smaller, they contain the lipid within them, and there's not nearly as many purple dots or immune cells infiltrated into the area. And this coincided with looking at the livers of these mice, where we can see with the high-fat diet, these little globules of lipid within the liver where it shouldn't be, Whereas with the mice that were treated with the high-fat diet as well as the drug, there is a massive decrease in lipid infiltration in these mice in the livers. And so following that, we wanted to see what were the pro-inflammatory chemicals that were released from the fat cells of these mice. So we cultured them in a plate and we measured the pro-inflammatory chemicals, and we could see there's a massive upregulation of these pro-inflammatory chemicals being secreted from these immune cells. But when they're treated with the anti-inflammatory drug, these pro-inflammatory chemicals are remarkably reduced. And that might be intuitive because we've given them an anti-inflammatory, therefore there's going to be less inflammation. And so what happened to HDL? And so, of course, HDL actually did regain its ability to take on cholesterol and transport it out of the body, but it also went back to college and got some new credentials. And so the proteins that associated with the HDL particle were actually anti-clotting. And that's really important in a heart disease context. And so with this graph, it might be hard to interpret, but basically this represents every protein that is expressed on that HDL particle, so on that shell. And so we have more anti-clotting proteins that are associated with the HDLs from the mice that were given the drug, but also pro-inflammatory proteins were more associated with the HDL from just the high-fat diet treated group. And so to summarize our initial question in the beginning, which is, can we reduce obesity-associated heart disease risk using an anti-inflammatory by getting HDL back to work? And what my research from my graduate studies shown that despite developing obesity, Sazoprin has allowed the fat cells to keep in the fat, reduces inflammation. But what I was really interested in was getting HDL back to work, but it has. And so even with Ireland or America's waistband ever expanding, we potentially are not sentencing people to the complications that obesity brings. And with that, what has that got to do with fiber and poop? Well, within my graduate work, I was given this wonderful opportunity to contribute to a book chapter for clinicians. And it was entitled Personalized Nutrition for Heart Patients. And given that I had such a personal interest in nutrition and food, I was tasked with investigating the macronutrient contribution to heart health. And so macronutrients are the main components that make up our food, fat, protein, carbohydrates. And most foods are made up of all three or a combination of all three. And while all are important for the maintenance and health of our bodies, any one macronutrient in excess can be harmful for one's health. And so over the last couple of decades, we've seen the popularity, a rise and fall of different macronutrient-based diets. So in the early 60s, fat was vilified. People made a turn toward carbohydrates for them to be then shunned in the 90s, where the popularity of Atkins became a thing. And now we're amidst a protein renaissance. So it's protein filled this and protein that. And it's like, are you getting enough protein? Are you sure you're getting enough protein? But what about the protein? And so traditionally, more attention and focus has been given to macronutrients in nutritional science and not on actual food. And so I believe this has led to disastrous outcomes. So when we talk about macronutrients, there are even more subgroups. So with fat, we have saturated fat, monounsaturated fat, polyunsaturated fat. And then with proteins, we have plant sources of proteins and animal sources of proteins. Depending on how many amino acids make up that protein, determine whether they're complete or incomplete. And then for carbohydrates, I think this is an oversimplified catch-all term to describe mono, di, and polysaccharides. And so mono and disaccharides are commonly referred to as sugars, whereas polysaccharides are more complex in nature. And so where does fiber feature? And why do I care about it so much? So technically, fiber is under the carbohydrate nutrient. And it's under that umbrella term, but is regarded as the undigestible part of a plant. The key word here being undigestible. So we as humans do not possess the enzymes to break down fiber. So when we eat it, it goes to our gut and is essentially pooped out. And it can come in multiple forms, so soluble, insoluble, fermentable, which are associated with the unwanted effects of increased fiber consumption, so flatulence or farting. And I'm not just talking about prunes or Metamucil as sources of fiber, but all these foods within this slide contain fiber. And so what piqued my interest in the first place? Well, during examination of the literature for this book chapter, it became increasingly apparent that increased fiber intake protected against heart disease, but also diabetes and weight gain. And so the mechanism by which fiber does this is multifaceted. So with regard to heart disease risk, fiber has been shown to reduce the amount of LDL, so that bad cholesterol, with having minimal effects on HDL, so the good cholesterol. So by reducing the amount of excess cholesterol being left in places where they shouldn't be, i.e. the arteries of the heart, we can reduce the risk of cardiovascular disease. So then when we talk about diabetes, I want to premise first that diabetes, type 2 diabetes, is regarded as a disease where there is a loss of glucose or glycemic control. And so when we eat a meal, for instance, white bread, where the fiber has been taken out, it's digested very quickly and broken down into glucose. And that glucose goes into blood circulation, and that spikes quite quickly. And this signals to the pancreas to release insulin, to then allow the cells to absorb that glucose to be utilized as energy. So the insulin acts like a lock and key. In a diabetic patient, however, the balance of this insulin to glucose ratio isn't controlled appropriately. And so the glucose actually remains in circulation for longer than it needs to. As a result of the glucose staying in circulation longer than it needs to, that's when we have the complications of type 2 diabetes, such as ocular degeneration or renal failure in the most extreme of cases. And so foods that have a high fiber content don't cause the same rapid blood glucose spike. And so the body has to work a bit harder in order to liberate the energy from that food. And so say you replace that white bread with like whole grain bread, less of it is absorbed in the traditional sense, and the fiber reaches the large intestine relatively unchanged. And so then in managing weight gain, because a fiber is essentially mopping up cholesterol and then reducing the amount of sugar absorbed into the body, there's an overall reduction in caloric absorption, which may be minuscule from meal to meal, but if you follow a high fiber diet over time, you potentially avoid unnecessary weight gain over time. And so these are just some examples of how high fiber may be beneficial from a macro perspective, but we're here for the nitty-gritty science. And so I've just told you that fiber reaches the large intestine relatively unchanged and unabsorbed. And so we as humans have evolved not to absorb fiber. So how in the world is it benefiting our health when the only exit from the large intestine is, well, the bathroom, but it's exactly in the large intestine where all the magic happens. And I'm probably one of the first scientists to ever juxtapose magic and the large intestine, but here we are. And so in the large intestine, there is a population that is more dense and more diverse than what we see in the Amazon rainforest, known as the gut microbiome. So there's trillions of little critters, bacteria, fungi, viruses, and archaea all exist in a symbiotic relationship to us humans, all within the confines of our large intestine. Fiber is the fuel source of our gut microbes. And so when humans evolved, so too did our guts to adapt to an ever-changing landscape where we foraged for wild fruit and vegetables, which were seasonal. And so for each fiber component, there was a microbial population that was able to eat it and digest it. And so the Hadza are a tribe that are based in Tanzania, which are considered the last hunter-gatherers of modern times. And they consume up to 100 to 150 grams of fiber per day. And so the diversity of their microbiome, meaning the different populations of microbes that inhabit their gut, is also exponentially greater than someone who consumes a standard Western diet. Interestingly, among this group of people, their longevity is comparable to people in industrialized nations, meaning that they're living just as long as people in America or Ireland, but they're not suffering from diseases such as heart disease or metabolic disease. And so how are these people living just as long as we are and not suffering from the main drivers of mortality in our nations? And is it the high fiber content of their diets driving this effect? As a standalone artifact, I'm going to say no, but I do think it is a really important contributor. And so what is increasingly becoming apparent with advancing scientific technology is the impact that the gut microbiome has on overall health. And so I want to first describe to you in a snapshot of what's happening in the gut on a micro level, and then hopefully convince you why a diet high in fiber can prevent the industrialized diseases afflicting the 21st century. And so here we have an image of the gut wall, which is 1 cell thick. And so this gut wall separates the contents of your gut, these microbes here, from your blood circulation. What's interesting is that 70% of the immune system is actually located within by the gut wall. And so we've already talked about how the immune system plays a pivotal role in the progression of diabetes and heart disease. So what if the initial embers that cause fire alarms for metabolic disease start in the gut? So whatever we eat has an impact on our microbial populations, which then influences our immune reaction to that. And so how does the body distinguish between components that promote wellness, i.e. are anti-inflammatory, or are a threat to our health, i.e. pro-inflammatory? And so we're not certain what this chain reaction of events, or what the exact cause is, but this chain reaction of events may give you clues as to what's going on. And so the microbiome, as I said, is highly adaptable, so that every meal you eat, there is a change in the relative concentration of the microbial populations that adjust depending on what you eat. And so imagine a person eats a highly refined and processed food diet, a diet that's generally lacking in fiber. This food is easily absorbed in the small intestine, with little to none left over for the microbiome in the large intestine, which I personally believe is a little bit selfish of you, so maybe cut it out. And so over time and continuation of this dietary pattern, populations of microbes die. So we see these microbe populations die out, and in some cases, the commensal or the good bacteria die out and become extinct. This allows for the not so symbiotic microbes to grow, but they're hungry. And so what they do is that they start feasting down on the lining of that gut wall and those cells. And so what happens is that that cell wall, that one layer of cells, becomes penetrated. And so microbial products then enter into circulation. And obviously the immune system is like, what the hell is going on here? There's microbial products coming into circulation. We need to alert the troops, get some inflammatory action going. And so this is a term known to describe leaky gut, or in the medical term, dysbiotic gut, or gut dysbiosis. And so this term is actually relatively new to the medical vernacular. But what if the cause of this growing trend of leaky gut is due to the increased popularity of highly processed fiber deplete foods? So the main takeaway point from this slide is that the reduction of microbial diversity, the microbes up here, and the increase of sinister microbial populations lead to a dysbiotic gut. And decreased microbial diversity is associated with metabolic diseases such as type 2 diabetes and fatty liver disease. Dysbiosis in the gut is also associated with these diseases. And so I hope you're beginning to see that there is a trend here in that there is a gut regulatory aspect to the progression of these diseases. And so on the flip side, we have an individual that consumes a predominantly whole food diet. I want you to notice that I'm not distinguishing between any diet that exists. Currently, just one that includes whole foods. So vegetables, legumes, whole grains, seeds, nuts, etc. The diversity of this whole food dietary pattern increases the gut microbial diversity within the gut. Work pioneered by Dr. Rob Knight in UC Davis pioneered this data and suggests that a more diverse plant-based diet makes for a more bacterially diverse gut. He did caution, however, that just because you have increased microbial diversity doesn't necessarily mean for positive health outcomes. But given that low microbial diversity appears to be a common theme underlying most chronic diseases, I think it's a viable hypothesis that the opposite can be true, where you have a more diverse microbiome, the potential for a healthier person exists. And so if we look back at the Hadza, they are one of the most diverse microbiomes to exist on this planet, and yet have the least amount of chronic disease. Is this a coincidence? Maybe so, but there is evidence to suggest a positive correlation between the two. And so delving even deeper again, what is it about microbial diversity that keeps our gut in tip-top shape? And it's basically microbial poop. You heard me. So the microbes in your gut that form your poop are also contributing to your poop by pooping in your poop. I had to practice that 5 times on my own in the mirror so I wouldn't laugh at myself by saying that. So I hope you're all laughing at home. So each bacterial strain has its own metabolism essentially. And once it's done chomping down on that delicious fiber you've ingested, the microbial populations then secrete their metabolites. And there's a plethora of metabolites that exist, but one of the most extensively studied are short chain fatty acids. So these little molecules here. So short-chain fatty acids have a multitude of health-promoting benefits. First off, short-chain fatty acids produced by those microbes act as a fuel source for these gut cells. And so the gut cells then can reinforce that barrier that prevents any nasty microbes reaching into circulation and getting into circulation. Short-chain fatty acids also have a role as an anti-inflammatory agent, primarily by inhibiting any pro-inflammatory signals that those gut cells might release. And so this signals to the immune system, we're one of the good guys, we don't need to alert anybody, the immune system can stay calm. And so there are a plethora of health benefits associated with the metabolites produced by these gut bugs. And so while good microbes are promoting driving health promotion within the gut and have positive health outcomes, so too do the bad bugs. So TMA here is a metabolite produced by the good bugs in your gut. Humans cannot, or at least we haven't discovered, any TMA producing enzymes in humans. And so as far as we know, any TMA that is formed is gut derived. And so TMA is formed after you eat foods containing a nutrient called choline. And choline is present in red meat, eggs, poultry, and fish. And so what happens is that you ingest these foods and the bacteria in your gut feast on that choline to then produce TMA. That TMA becomes oxidized in the liver and then is released into circulation. TMAO is a single an independent risk factor for heart disease, in that if you have increased levels of TMAO, you will have a correlative risk of heart disease risk. And so if you've got like a vegetarian or a vegan that doesn't eat, or a vegetarian that doesn't eat eggs, or a vegan, they won't have levels of TMAO because they don't have the gut bugs to actually make that TMAO. And on the flip side, if you have a person that enjoys eating meat, they will have TMAO present because they have the microbes that can actually use that choline. Just as a disclaimer, though, I'm not telling people not to stop eating meat or eggs, because choline is actually a very important nutrient as part of a healthy diet. But maybe too much of it is probably not the best. And so beyond the interplay between overall microbiome composition and the inflammatory action within the intestine and then gut wall permeability, I hope I've convinced you that there's a very real link between what is happening in your gut and it has a real impact on your overall health. And so with all that science, what does that mean for you, the audience, in an environment where we are constantly shoveled information of what the best diet is for optimal health? And how can you as consumers determine what the best option is? And we can talk about cholesterol or immune system activation and also the microbiome that gives us the scientific data to back up our claims that certain foods do this or that. But when it comes down to it, at the end of the day, diet is the single leading predictor for all-cause mortality and total chronic disease burden, meaning that the dietary pattern that you abide by determines your disease risk, but also your health span, i.e. your quality of life. And so our focus has been on energy density, on how many calories are in this food stuff, or what the macronutrient composition is, whether it's high in protein or low carb, or whether there's the addition of fat, sugar, or salt. And if it's been taken out, what has it been replaced with? And so I think there's been personally too much of an emphasis on the processing of real food. And our focus has become muddled. Science does not give a beep about labels. And so what is becoming very apparent is a common theme among dietary patterns, which have consistently been shown to reduce disease risk and enhance lifespan. And so this incredible review by David Katz, who's an MD in Yale, published in the Annual Review of Public Health, looked at every diet that exists: low carb, low fat, Mediterranean, paleo, vegan, and mixed diets, and concluded very succinctly: food, not too much, mostly plants. And so whole foods became a common denominator in diets associated with low level of diet-related disease. And so that meant a diet that favors minimally processed, direct from nature foods, and avoiding refined starch and added sugars. And so there's always room to follow any diet plan badly. And I just want to illustrate here that with three popular dietary patterns that exist and are in many cases quite extreme in their etiology. And so we have low fat, we have vegan, and we have keto. And so if we look comparatively, despite these diets being incredibly different in nature, I'm sure we can all agree that the components that make up these diets are incredibly unhealthy, Jesus. Healthy, not at all. But if I change the components to these, which fit into the same categories, this changes things drastically. And so at the end of the day, we want people to be eating to satiation without the risk of overeating and becoming overweight. They also need to be consistent with their dietary pattern. I'm sure everyone has experience in trying a new fad diet for old habits to creep back in. And I think the emphasis should be placed on small habitual changes that reap bigger rewards in the long term. So basically that 1 week juice cleanse is not going to undo years of bad eating. And so we can get into a conversation about ultra processed and not so processed or whole foods. But what does the science say? Because we know that ultra processed foods are highly palatable, but they lack fiber, they lack a lot of nutrients, but they're so satisfying to eat over a whole food diet. But is this actually true? So Kevin Hall, who is a scientist based in the NIH here in Maryland, set out to answer this exact question. And so we've got a group of people within a metabolic ward and tracked what they ate. So before this, traditionally, how people report or monitor what they're eating is through food frequency questionnaires. So you send off a person or a participant, and you tell them to write down exactly what they ate, and then they'll come back to the scientist, and the scientist will deal with that information. But I don't know about you, but I don't really want the scientist judging me when I ate 3 slices of cake for lunch. So I'm going to put down 1 because that seems reasonable. So instead, what Kevin Hall has, he set up this metabolic ward in the NIH, and so the people actually have to stay there. And so everything is tracked. And so for 2 weeks, they're given an ultra-processed food diet. And then for the next 2 weeks, they're given an unprocessed food diet. So they're there for a total of 4 weeks. And this allows for each person to be their own control. Because if you had 2 separate groups, then you could confound the results to, oh, this person A actually preferred this diet, or person B preferred that diet. And so for each study, they were asked to eat till satisfaction, with no limitations whatsoever. What was interesting about this study was that on both diets, the groups reported the same level of satisfaction, meaning they ate to their heart's content, irrespective of what the diet they were on, with no difference in macronutrient ratios. So despite one being an ultra-processed food diet and unprocessed food diet, they ate the same amount of fats, they ate the same amount of protein, and the same amount of carbs. But when they were on the ultra-processed food diet, they had to consume 500 calories more per day to reach that same level of satisfaction. So meaning that, so it leads to the question of, like, are we actually shooting ourselves in the foot by eating ultra-processed food, ultra-processed foods? Because in the end, we will want to consume more because it just tastes good. And so we talked about macronutrient composition and its contribution to what, and that contribution. What we really want to know is, what about that fiber? Do they control for fiber? Because otherwise, this isn't a really scientifically sound study, is it? And they did control for the fiber. But you're going to ask me, Dr. Serena, how did they get fiber into an ultra-processed food diet? So they actually used a supplement, and they put it in their drink. And so these both groups were controlled for the amount of fiber that they took in, and even though they had the same amount of fiber, that wasn't enough to disencourage them or dissuade them from the highly palatable want for ultra-processed food. And so what I'm getting at is that we cannot extract a component of what we think is the main driver in promoting health by supplementing it into a bad diet. And so what is becoming increasingly evident is that the oversimplicity of breaking down foods into just macros or just caloric just calories or the fiber content is confusing, but also potentially dangerous for the general public. Given the weight of evidence that exists, the optimal diet appears to be a diet rich in fiber from multiple plant sources, with or without meat. And it's not a case of being dogmatic or puritanical. We live in an environment where it is too easy to pick up a bag of crisps or get a takeout. But I think making small sustainable changes over time can reap big rewards. And this investment into your health now can potentially prevent paying for medical bills later. So with that, I'm going to end my talk with some shameless self-promotion. So you can contact me or follow me on my social media. I'm on Instagram and Twitter at Serena Kajani, where I share recipes that are heavily influenced by my South Asian heritage, but also remake classic staples using with a fiber influenced twist. I also try to include instructional videos and give macronutrient, calorie, and fiber breakdowns for all my recipes. I also post a new recipe on my Patreon, which is a subscription service. So if you want to endorse me for the things that I do, you can. What I'm trying to do is just to get people more aware of the science and cognizant of the food that they're eating in order to make a more informed and healthier decision for themselves. And with that, I would just like to thank you, the audience, for listening to me for 40 minutes talk about fiber, which is unbelievable, but also to acknowledge my old lab and my supervisor, Dr. Fiona McKillicuddy, who has been an awesome mentor and always encouraged me to do these outreach things. And also as being a woman in STEM, it's great. And with that, I will take any questions.
All right, Dr. Kajani, we do have some questions stacked up in the chat here. So when you talk about choline coming from animal products, is that also from dairy products or specifically from like meat and eggs?
I believe you can get choline from dairy products as well, but I would need to double check that. I can't say for certain, but I'm almost I'm nearly there that dairy products would have choline. But choline, like as in, it's not about if you're going to have just because there's choline, like choline is present in plants and stuff, but they just don't know how much choline is appropriate. But they just know that there is a link between choline and the increase in TMAO. So it's not about worrying too much about how much choline you should be getting. It's just if you eat a diet that is rich in plant diversity, those nutrients will look after themselves.
Okay. So what can you tell us about probiotics? What's your opinion on probiotics?
Oh, that's a great question. So I was initially of the school of thought. So probiotics, just for anyone that doesn't understand what they are a supplement that you can take of bacterial species in a pill form. And depending on what their outside of the capsule is made out of can depend whether it actually reaches your gut or not. And so because I actually worked in a pharmacy for 8 years, and anyone that came off antibiotics was given a course of probiotics in order to just replenish their gut microbiome with some species. But the problem with probiotics is that every probiotic on the market has their own milieu of probiotic strains, and some might have just 1 or 2 at a really high density, or another one might have 5 or 6 but at a really low density. And so if you find that probiotics work for you, all well and good, in order to get a good one, I think they cost at least $40, $50 a month, but you don't necessarily have to take one if you're eating foods that are rich in plants. But also there's new data also suggests that taking a probiotic after an antibiotic may not necessarily be the best thing. I'm just going to disclaim this with I'm not an MD or a clinician, so you need to double check with your doctor. But the data that's coming out is that a probiotic after an antibiotic reduces your body's capability of proliferating your own microbiome. So what you should do after an antibiotic is start off with shakes and soups and stuff that have all the phytochemicals associated with plants, and that actually will nurture your microbiome better than taking a probiotic.
Okay. So have you seen anything in your research where there's the relationship between a high fiber diet and decreased risk of colon cancer.
Oh, yes, absolutely. So the focus of my stuff is mainly on metabolic disease, because that's the area I'm interested in, given my past with obesity and stuff. And so that is generally like my area of expertise. But high fiber diet has been shown time and time again to decrease colon cancer risk, 100%.
Okay. So can you speak to how important is the variety of food sources that you're using to get your fiber intake? So if you're just consistently eating the same things all the time, um, is that more beneficial than eating a wider variety?
No, so the data is actually coming out. So there's a reason why I didn't actually put the amount of grams of fiber that is necessary for a person to eat. But for anyone that is interested, it's 25 grams for women and 39 grams of fiber for men per day. But what the data is showing, that it's not actually about the grams of fiber, but actually the amount of different plants that you're getting. So the more diverse your diet is in terms of getting those things that have fiber in them, so whole grains, plants, seeds, nuts, vegetables, legumes, all those kind of things, the more diverse that is, the better your health will be. But in saying that, if you have a diet that's high in those things, the fiber will follow itself. So you won't need to worry about the grams of fiber, if that makes sense.
Okay. So can you talk a little bit more about the variation of the effects between soluble and insoluble fiber?
Oh, yes. So soluble and insoluble are basically whether the fiber likes water or not. So if you have insoluble fiber, that fiber does not dissolve in water and is generally regarded as the stuff that causes the bulk of a stool. Whereas the soluble fiber does react with water, or it will dissolve in water, and that gives you the gel consistency of your poop. So there you go.
Do we observe there's a decrease in overall HDL with obesity, or a decrease in the function of the efficacy of HDL with obesity, or both?
So that's a really good question. And so with obesity, there is a reduction in HDL levels, and that is a proxy for those transporters. And so when there's a lowering of that good cholesterol, that means it's not whether and wait, let's start this again. There is a lowering of that good cholesterol, which means that there's less particles being able to remove cholesterol from the body into excretion. But also, just because the number is lower, are those particles efficient at picking up that cholesterol? And so we know for a fact that obesity actually reduces HDL's ability to take on that cholesterol and remove it from the body.
So what's your thought on processed foods with high fiber content?
Oh, that is a great question. And so I appreciate what fiber company or big food companies are trying to do. I think fiber is going to have its limelight soon. It already is with the likes of Fiber One bars. You can get high fiber sweeties and stuff. And I think it goes back to the thing that, well, we shouldn't be eating highly processed foods. And so if you can get your food source, your fiber from natural food sources, that's going to be your best bet. But if you're trying to reach your fiber goals and you're finding that it's difficult, supplementing may be okay. Like I know, for instance, when I started with my fiber thing, I got really into eating protein bars that were high in fiber. But then I also noticed that I was getting these like awful tummy pains, and so I stopped eating them and now make my own like high protein fiber bars and just with natural ingredients. And that makes it so that I include more plant diversity because there's a multitude of nuts and seeds in them, and my protein powder. But it's also, you need to start listening to your body. So when you say, for instance, have a highly processed thing that has loads of fiber in it, and then you're getting tummy pains or it's causing flatulence, that's a good indicator that it doesn't really agree with your body, and so you probably shouldn't be eating it. But try and introduce other sorts of fibers that are unprocessed, and they probably won't have the same effects.
So I have a question myself. So if you want to increase your fiber intake, that is something should you do it gradually? How would you recommend someone would do that?
Okay, so if you're someone that has never eaten fiber before and decides, okay, Dr. Serena said I should be 39 grams of fiber, let's get on it. do not do that. Your body, your microbiome is not equipped to deal with that amount of fiber so suddenly. And what you'll have is you'll suffer from abdominal pain, bloating, cramping, probably diarrhea or constipation, or both at the same time. Who knew that could happen? And so you want to start adding things in gradually. And so what I would do is start off with, say for instance, lentils, or just have like a small serving of them. Then and see how your body feels after you eating that, and then adjust accordingly, and just increase the amount of those kind of foods incrementally. So say for instance this week you have 5 grams or 10 grams of fiber, and that you know that you've accounted for, and then and see how you feel, and see, like, monitor your poop. I think it's really important. I know it's kind of gross, but like we all do it, so why isn't there more focus on it? And see how you feel, and then increase or adjust as you go on. For someone that has never eaten fiber at all, like as in has a diet that's predominantly made of unprocessed foods, I would maybe start off with like shakes or soups, because they're a good way to start like massaging the microbiome to become ready for the more fiber that you're going to eat in due time.
Okay, Dr. Johnny, do you have any data about maybe adjustments in diet kind of helping with the leaky gut syndrome?
So in terms of the leaky gut syndrome, the thing is, the great thing about the microbiome is that it is highly adaptable, and it will take time to repair that, but you can. And so again, as I said before, with someone that hasn't taken in a lot of fiber, you want to start off with like soups and shakes, stuff that you can get a multitude of plant diversity in, but without having as much, I suppose, having to work towards getting those nutrients from that food. And so someone that is maybe suffering from a leaky gut, if you start having like a blended juice, and try go for like the greener side of juices rather than a load of like fruit-based juices, because they do have a lot of sugar, and then soups and stuff, and then that can start again just massaging that gut to make it prepared for eating more fibrous foods. And so at the end of the day, plant diversity is going to heal that, but how you incorporate that into your diet is really important, and I think going slow is imperative.
Okay, so I think everyone's probably seen those little ads that pop up at the bottom of the webpage talking about some vegetables are supposed to be less healthy for you, or actually even bad for you. Can you address that at all?
Yes, and you know what? Everyone's made up different. Some vegetables and some things are going to be more agreeable or disagreeable with you. But in terms of these inflammatory messages that say a certain food type from Mother Nature is good or bad for you, I just think it's nonsense personally. And unless you have a real intolerance or an allergy to something, I don't think for the majority of people that a vegetable or a fruit or like beans or nuts or seeds are going to be bad for you. We as humans evolved, and we're 200,000 years of evolutionary biology. We needed anything that the world gave us, because we did not have processed food available to us. And so for people charlatans, I'm going to call them charlatans, to come out and say tomatoes are bad for you, well, to them I say you're lying.
All right. So we did have a question about beans specifically. So if I want to eat beans, does it make a difference if I eat canned beans or if I take dried beans and then cook them? What can you say about that?
So in terms of their fiber content, it doesn't actually change much. Personally, I use canned beans all the time because they're easier. They're already, you don't have to soak them. Like soaking beans and then waiting for them to cook, and they do have a different texture the next day, is pain. And like, we live in a really fast-paced lifestyle. No one has time to be soaking beans. So yes, you're fine to be eating canned beans. The only thing about canned beans, I would say, is just watch out for the sodium content. So just rinse them a good couple of times. I know for the recipes that I post, I'm like, who has time for rinsing? But if you're worried about your sodium content, do rinse them. But yeah, that's all I have to say. Otherwise, they're still as nutritionally dense as the other beans.
So I am getting a few questions about people asking, for older adults, is it ever really kind of too late to change your diet?
I don't think so. I think that you still have loads of years left to live. So why punish yourself by not giving your body the opportunity to feel better than it did yesterday? I don't think that. I think, just again, like I say, the small sustainable changes. I'm not saying, oh, drop everything and stop eating pizza. Like, I eat pizza on Fridays. I enjoy my pizza, but for the most part, I do eat a plant-based diet. And if you're not used to that, just for instance, just add one vegetable to your meal, and then over time that will change your habits. And yeah, I to answer the question, like, in short, no, it's not too late.
All right, so if I could go back a little bit to when you were doing your PhD work, when you're talking about the anti-inflammatory drug, the Zasprin. So would that indicate that people should go out and start taking anti-inflammatories?
Please don't. If there's anything from this talk, please do not start going taking anti-inflammatories. This is a study that was done to see, a preclinical study to see if the anti-inflammatory would have an effect. I know that baby aspirin, the 75 milligram aspirin, is available over the counter, and that has had positive effects on health for people. But again, consult your MD, consult your clinician. I am not a doctor. I think that a body that is anti-inflammatory is going to be better for you in an overall health kind of way. But yeah, don't start chugging aspirin without the guidance of a doctor.
All right, so I did have a question. What about seeds and nuts?
Nature's bounty. What you want to know about seeds and nuts? Eat loads of them. So, in context here, I think what the question is probably pertaining to is, well, seeds and nuts are pretty calorific, and obviously calories do matter. But having almonds and dark chocolate as a snack instead of a Snickers bar is definitely better than the Snickers bar. And so it's just, what is it relative to? If you're going to eat a whole bag of nuts and that's about 1,600 calories, well, obviously that's not going to be better than if you were eating 1,200 calories that didn't include the nuts. And so just being smart about what you're eating. So like, I would eat seeds. Probably I have like a tablespoon of chia with my porridge in the morning, and I have a handful of nuts as my snack at work. It's also just being mindful, and then also being mindful of, like, when you're full and when you're hungry. Oh my God, good one. But yeah, that's my take on that.
Can eating an excessive amount of fiber be bad for you?
I think in westernized culture, yes. Given the fact that most people don't consume a lot of fiber. But I did mention that the Hadza do consume 100 to 150 grams of fiber. And the reason for that, I think, is because in order to get the energy that they need as hunter-gatherers, they need to consume a lot of things that are predominantly raw and plant-based. Whereas in westernized culture, we can actually eat a lot of fiber fairly easily if we really wanted to. And then you can tip the scales on the other end, where you end up consuming too much, and that can cause diarrhea and constipation. I think it gets to a state where you like need to listen to your body and see where it's going. If you are suffering from like constipation or diarrhea, then you know that you might have to taper it or adjust accordingly. But like for me, for instance, I probably eat about 60 to 70 grams of fiber a day, but that didn't happen overnight. It's taken about 3 or 4 years of consistently adding different types of fiber into my diet, and my body has adjusted to that level of fiber consumption. So yes, in short, yes, there can be too much fiber, but it's obviously dependent on the person.
All right, looks like we're out of time for today. Thank you, everyone in the audience, for joining us. Dr. Kajani, thank you so much for being with us. Great presentation. Please join us next week at noon on Wednesday with Dr. Roger Hanlon, Senior Scientist at the Marine Biological Laboratory at Woods Hole Oceanographic Institute. And he's going to be presenting his work on the flamboyant cuttlefish and rapid adaptive camouflage and signaling in cephalopods. So if you love cephalopods, and I do, you definitely will want to tune in next week. We've got some great speakers coming up for December. We are going to have NASA back with us, talk about the Artemis mission. So do be on the lookout for that. So you can register for Dr. Hanlon's talk next week at smv.org. Each talk is free to attend and open to the first 300 registrants. Thank you again for joining us today. Until next week, stay safe and stay curious.